Today's session is T-11, power supplies. The power supply provides a number of connections for various devices as well as a plug for the motherboard itself. As we heard, I called it by mistake the T1 as if it was a Terminator, but we learned quickly that it was called a P1. It is important to understand these connector types that we're going to be reviewing today and to appreciate and understand the power drawn by these various devices. Our knowledge of what type of power is required and then its needs, depending on the amount of devices we have in actual computer, is needed, especially if we're going to be creating these different types of computers or the gaming PCs, whatever it is. If we're going to start to add, we need to be able to identify exactly what type of power supply we're going to need, what is the exact connectors required, and select exact power supply size by wattage, remove and identify how to install the actual power supply in various computers, and obviously ATX boards on the actual PCs is pretty easy, and identify our common problems that may actually come up. As we've learned, power supplies give us connectivity to all components inside this computer. In order to understand how the actual power supplies function, you have to understand how electricity actually functions. If we don't grasp this fully, it will confuse the living daylights out of us. One of the things we're going to learn today is electricity flows either through an alternating current, AC, or a direct current. I believe we covered that also in the previous session. Electrical devices run on direct current. Hence, we need power supplies to be able to convert from AC to DC, and no, it has nothing to do with the rock group. When building a PC or exchanging a power supply, you have to choose the appropriate PSU, power supply unit. If not, and if you don't consider the actual wattage, what type of form factor case do you have, and the number of cables and connectors that you're going to require, you will be buying the wrong thing, especially if you're building it yourself. We also need to be able to follow a series of steps when replacing or installing an actual PSU.
I have a question.
Yes.
Sorry to interrupt you.
Not a problem.
The question I have is, wouldn't it be more efficient just to tailor or create our electronics to use alternating currents rather than to rely on thing that turns one into the other?
You want everything to use AC instead of DC?
Yes.
From my understanding, at least my understanding, electricity, AC tends to work better in long distance and DC tends to work better in short distance. And on top of it, when you're dealing with direct current from your computer wise, it's going only one way. You're not going to be alternating current, sending back current. Remember, alternating current goes positive and negative, alternating. The only device that I'm aware of that uses AC and has an a DC AC converter inside of it. Can anybody tell me which one's that? There is computer devices that require it to actually go right back.
And it's pretty old nowadays, I guess.
Yes, it is. The old laptops, their screens, I believe, was it plasma?
Yes.
Was it plasma? Plasma required you to actually convert it back to AC. But as for inside the computer components, you want the current going one way, direct current. I can't see, I haven't heard of any PC that's running on AC. Plus, also you need to have the power supply unit who is downgrading these things. As I said, it only takes up to 12 volts. If I throw 110 volts directly onto that board, I could only imagine what might just happen right after that.
That fun burning smell you get every now and again.
Yeah, might be, might be, might be. This is in the physical book in pages 113 through 122, just in case if for those that were wondering and didn't read your actual book. Overall, our BSMs that we will be using is communications and growth mindset due to the fact that we need to be able to communicate clearly on what our requirements are and growth mindset to be understand all the different intricacies that are going to be required because your brain's about to get fried. In reference to that fried feeling, electricity, here we are. Fadil, if you can help me out with this slide, please.
Understanding electricity. Electricity is a flow of negatively charged particles called electrons. The pressure of electrons in the wire is called voltage and it is measured in volts. The amount of electrons moving on one wire is called current, measured in amperes. The amount of electrical power is called wattage, measured in watts. The correlation is W is equal to V times A. Wires have resistance to the flow of electrons measured in ohms.
Thank you. So basically, as we learn, hopefully in science class, electrons are those negative particles that you could see around an atom, if we all agree. So using the amount, or you can think as that as being a little water particle. Play with me in this comparing water to electrons. So you have that little drop. That is an electron. Now, in reference to volts, that would be the amount of pressure that's coming out of a water hose, per se, the amount of pressure of all those electrons flowing through there. The next one, which is you would consider the amount of electrons moving on the wire itself, which is called the current or the amps. That is equivalent to most of you will probably notice what amps are because you have it in your little panel, either in your car or in your house, where the actual little fuse box goes off. You'll notice that they have 60, 20, 10, depending on the actual amperage of the wire's resistance, which was the word we learned down there. So the resistance of that wire, depending on the amount that you could actually pull based on the gauge of that wire, it will have an amount of amps that can actually flow through there. The actual amount of electricity or wattage, as we learned, now we have the volume, which is the pressure. Then we have the amps, which is the amount that's actually getting pulled into this, right? Amps, the current. And those two, when you multiply it together, give you the amount of watts required. Why do we need watts? With this, we know exactly how much voltage is the device going to be actually using, and we know the amount of amperage, which is the amount it's going to be pulling. With those two, it gives us that number. This is what we need to be able to identify exactly what type of power supply unit we will require. Any questions or doubts? None? All right, we're all professional
Oh,
electricians.
when would
Yeah.
you use the equation for something like that?
When purchasing a brand new power supply unit or upgrading or creating a brand new computer by scratch, you will need to know all of this. You also need to know it. For example, if your boss comes up to you and says, "Hey, I need a UPS that can cover all the switches and routers in this room, the servers included." Now you got to go into these devices, find out what they call the starting amount of wattage it's going to be using, because that's the one that you're going to get hit with at times. That you need to be able to cover. You know how your car turns on, it goes, it takes more energy to start the car than keep it actually running. Do you agree? To start a car or anything, it takes more energy to start it than to keep it running. Yes or no? Yes, no, maybe so. Hello?
Yes.
Yes, it takes some energy to start.
Yes.
Okay, thank God this mic worked. Okay, so this starting energy, you need to be able to calculate it in watts. So that will be another reason why. So if either for your battery backups or even where you're going to be connecting. Let's say you're bringing up a server room and they're telling you to put all of this equipment. You need to be aware of everything that's in this room, which plant engineering or somebody in the engineering group is going to give you exactly how much you could actually pull from each of these different sockets that you have available to you. So it's everywhere. Wattage will be asked for you to be understand pretty much anywhere, be internal in the computer or even external, depending on your position.
I have a question.
Mhm.
So in terms of pressure and current, right? So can the cable hold more pressure than what can be, uh, I guess, allowed through, or
That's
or
what,
like,
yes, yes, it will allow, it will do that, but that's where we get the little joke where you get that burning smell. The
okay,
wire
okay.
will take more than what it's supposed to. That is not a problem. But in doing that, it will burn because of the fact the amount of electrons that are moving through there, its resistance can only flow so many electrons through it. Just so much it can actually pull. You'll also notice this happens to everybody that puts a printer or maybe even a hair dryer on a UPS or one of those little power strips. All of a sudden, when you put that there, because the actual power strip or the actual UPS is unable to deal with that wattage because the pull is too much for the wires that it has inside, it will go beep, boom, and just drop to make sure that the unit does not get damaged.
So the equation isn't. So the equation is also taking under consideration I guess the stress level that this wire can handle at the same time as how much current it can
The
pull.
the equation will give you the amount of wattage. The resistance gives you the amount you can flow through there. But either which way, the equipment will tell you how much it's going to be using. The equipment's going to give you a little tag, or you could look it up in the internet exactly how much it's watts, how much it needs. Like for instance, the if you get the actual hard drive when you purchase it on the box, it should tell you. The motherboard itself, also, if you purchase the motherboard, it should tell you how many watts. The DVD, even the actual graphic card, whatever it is that you're installing in here, will have its own watts rating and it lets you know exactly how much you need. Obviously, the cookie cutters, the ones that you actually buy already built, you wouldn't need to understand anything unless, of course, if you start having issues in the point that you start adding these huge graphic cards and all of a sudden you are able to turn it on, but you get nothing on the screen. That's a good hint that most likely you ran out of watts and it's not able to power up this actual new graphics card.
And Nat, I think you're concerned about the wires. Keep in mind, there, this process has been going on for some time. You would, before your wires have an issue, unless it's unforeseen, catastrophic, other issues would happen to shut that system down. You're not.
Mm-hmm.
It's not like putting 212s in your trunk and getting too small of a power wire and it burning through in that regard. All of those wires, because of the amount, is so minuscule to an extent. We're not expecting wires to burn out of your power supply unless,
Mm-hmm.
like I said, some issues catastrophically is going on, and
Mm-hmm.
and those are very minuscule. So don't be too hung up on the wires.
Internally, yeah, I would have to agree. Internally, you shouldn't have that problem because the power, unless if the power supply unit itself has gone haywire, and when it's actually doing the conversion to DC, it gives you the wrong amount. And we'll see here that it has its own rails for every different voltage to ensure that it only gives to those specific rails that voltage. As for
Thank you.
AC, no problem. AC itself, Shiloh, help me out here.
Alternating current oscillates between negative and positive voltage. AC travels on a hot line from a power station, then AC returns to the power station on a neutral line. The neutral line is grounded to prevent uncontrolled electricity in a short. Standard AC in the United States comes in somewhere between 110 and 120 volts. 115 VAC. Europe uses 220 to 240 volts. Direct current travels in one direction and is the type of current used by most electronic devices.
Thank you. As for AC, as we see, it goes both ways. Usually used, as we see, from the actual power station to your houses. Then usually the majority of your equipment have some type of power converter. It will convert it to DC to the amount that is required. Because you could just imagine if every single device inside your house was using 110 volts internally, that would be a lot that is drawing, and you would require more than 110. And on top of it, it's an alternating current, and that I'm aware of, as it states here, the majority of electronic components nowadays or devices like computers use DC. Question, doubts? Here we are. This is an internal of a computer and its guts. We see all the variants of different wires in there. We're gonna learn now what the yellow wire is, the black ones. We have the different connectors that we've seen. As we just learned, the actual power supply itself converts from VAC to VDC from either 110 or 220 itself. It has usually a switch selector, or it may be an auto selector if it's the very expensive one. Otherwise, you will have a in the back of this case a little red option to be able to select the actual voltage. Internally, the computer only has positive 3.3, positive and negative 5, and positive and negative 12 volts. It provides DC connections to obviously use within the actual computer, and as we stated a moment ago, is measured in watts, which is the volts times the actual amperage that every device uses.
Test question. They will ask about those particular high-low power numbers there.
And they'll also ask you in reference to these devices. As for the actual P1 here, you'll notice that when it comes from AC to DC, to understand that the 20-pin connector itself brings in the 12, you have the 5, you have also a 5 here and another 3 area. We'll see the details of each one. There's also one for standby, which we'll look in a moment. As for the little switch, as we stated a moment ago, they usually have that little switch in the back. That's the red thing that's actually circled out there, where in the left side it goes to one area, B110, and the other one is to 220 itself. As in everything, 0 means off, 1 means on. This is a kill switch that's usually on the back of most electronic devices like your routers, your computers, and anything that has a power supply unit like this one. Now, any questions, doubts?
So going back to the last slide about converting it from American voltage to European voltage. So when you have like one of those adapters for when you go to Europe, how is it able to be able to be more power than like the American voltage when you plug it in? If that makes any sense.
Okay, when you were talking about a laptop, or are we speaking about
Like, for
a,
example, like a simple little adapter that you just to plug in like a phone or to plug into charge or anything like that.
it has to be rated for the actual voltage that you're plugging in, and that adapter will then convert it to the DC that it's required. But the equipment or the adapter must be able to handle the actual voltage that's coming in.
I got a good story about that because I did
Yes.
something big no. When I was in Israel in the Middle East, I had an Xbox that came from America. I used some random adapter, plugging into the Xbox, and when I turned it on, it exploded. And I'm being truthful. It exploded inside. Didn't get on fire, but it exploded, and that's because it could not handle the voltage. So just because you can change it, doesn't mean the other device can support it.
And Mike, if you look at your notebook adapter, your power adapter, it'll
Mm-hmm.
show you the range that it has. It
Mm-hmm.
may not have the appropriate plug for the wall, but it has
Mm-hmm.
the ability built in, just like with these desktops having the opportunity to switch that switch
Yeah.
from those. So you, like, unlike Lazaro, most of your devices may be equipped with it, but no need in the States to have those extra adapters.
We do need to take note. The ice cream truck just passed by. It is 1:02. I do apologize. At 1:07, take your 5-minute break, and I'll see you guys here at 1:07. 1:07. That would be Eastern 1:07. Mountain, don't even play. I'll see you guys in 5 minutes. Turn on, and anybody want to understand why mathematically that won't work? It won't explode. I'll give you that much of a hint. So what happens? Why won't it turn on?
It has like a protector thing.
Well, I'm gonna buy the correct plug adapter and everything. I'm gonna plug a 220 device into a 110 volt, but it just doesn't turn on the device.
Is it not enough power going
That
through
is
the wire?
correct. Mathematically, I'm missing 120 volts there. Am I not? My amperage may be exactly the same that I'm pulling, but unfortunately, it's expecting so much. It's equivalent to going and sticking a garden hose onto a fire hydrant. It just doesn't make sense. You wouldn't be able to stick the amount of water in there, and then basically the flow is just minuscule because you put the big humongous fire hydrant on that little thing. Just not the right thing. That's why it won't turn on if you want to think about it logically in that manner. Thank you. Questions or doubts on this? I know we had some other questions. I want to make sure we answered them the one right before the break. Everyone clear in reference to? All right. In
I
the
have a
back we have,
question.
yes, go ahead.
Could you explain the difference between minus and plus on the 3.3 and 12 and 5?
The computer has only a positive 3.3, which is usually in a floppy device, which we'll get into that detail in the slides that are coming up. And then the majority of the computers use a positive and a negative voltage in the computer of 5 or 12, depending on the device again. And we learned also that the 12 or the 5, or depending if they're small enough the device, it'll use the 5 and the 3 to create the ones and zeros. Based on that information, it's able to write electronically onto the device.
Okay, what is a negative voltage? That's my question.
Negative charge versus a positive charge electron. Or that's what it is in electricity wise. Remember in science class how they taught us there was a positive one and there's a negative one? That's basically what it is. In reference to details of electricity, I am not an electrical engineer, so I can't get into the details of how that flows of energy, but one is a negative one, while the other one is a positively charged one. Compare that to I could tell you in a magnet, how's that? You know how it has two poles? There's a north pole and a south pole. Have you ever played with a magnet and you try to actually put two south poles together? It pushes away. You could consider that the flow of energy, or the flow, in my case, of electricity would be a negative flow. Versus if you invert that, now you go positive, right? It has another one. But if you put the two opposites together, they stick. Therefore, if you ever try to do that with a car battery, put the negative and positive, it will spark because of the flow of energies are in opposites.
Nicole, do you know how it goes up and down and up and down? So that line is going positive, then it's going below the cutoff, and then going down into the negative. So each device can receive energy depending on what it's labeled as, from that top of that to the positive side all the way down to the negative side. So it's just whatever the device needs to work. That flow of energy doesn't just stay positive all the time. It goes down, it comes up, it goes down, it comes up. And as it flows, it's powering those devices. And like Diego said, creating those ones and zeros, which is the communication for the computer.
In AC, it does it by itself. The alternating current is alternating, and that's in its name. Hence, here in the direct current, you have to tell it which one you want. I hope that helps out.
Okay, thanks.
Okay, in the physical switch, now we got a much clearer picture here from the other ones. Well, we'll see here the actual little doohickey where we come in, the black cable that everybody's used to seeing with the three female connector. This one obviously on this side is the actual male connector where we can and connect it directly to the wall. The red switch on the right there is where we see that the actual dip switch to search from 230 to actually 115 that they taught us earlier, right? Because it flows average about 115, anywhere between 110 and 120. And then here they have the 230. Again, the little kill switch there, we have the main one to turn off completely. Obviously in the front to be able to soft reset, we have that little soft power reset in the front panel to be able to just either restart or turn off the computer. We always have this here in the back of the majority of the ones that have a PDS unit like this, a kill switch to ensure that you could be able to kill it if it does not want to respond to the soft switch, as we'll learn or learned in the previous chapter on the motherboard. The actual front panel has a soft switch that connects to the motherboard. So if the motherboard is failing to tell the actual computer to turn off, this will obviously kill all the power and bypass the actual soft switch. Questions, doubts? As for our cables and connectors, we have Kevin, help me out, please.
Cables and connectors, power to motherboard, 20 or 24 pin connector called P1. The 24 pin is the most common in modern PCs and it could be backward compatible. Provides 3.3 volts, positive negative 5 volts and positive negative 12 volts to the motherboard. Some motherboards required special 4, 6, 8 pin connectors to supply extra power to the CPU.
So these, thank you very much, are the main connectors here. You'll notice that this one has either a 20 or a 24. Anyone know what these 4 extra ones here may be for?
For the video card?
To make, it's for the motherboard.
Correct.
For the 24 pin.
Correct. But why? I think somebody just alluded to what is this usually for? I'm sorry, somebody said that.
Somebody said
the
somebody.
video card.
Yes, sometimes a GPU requires this extra power, especially the new ones require that extra power. And from my understanding, they have this one. Then you have this extra one on the bottom, which would be another spot for the actual one that we saw from the video when the guy was installing the kit from Intel. This is the actual connector where you could actually go and connect the actual motherboard to give it the power for the actual fans.
The 24 pin is the one that is the one that we're seeing on the picture, right? We're never gonna see 16 pins all together and then 4 separate for the graphics
Yeah,
card.
the original, yeah, that is a very good question. Thank you for that question. You are correct. The P1, the original P1 was always 20. You would see the extra 4 in the later models because the majority of them, well, that I'm aware of, all the new motherboards require the 24 pin connector because as we learned of the North and South Bridge, the majority of them now are using PCIe, AGP, and PCI has become antiquated, and a lot of them are not using it. Therefore,
Is
it's a
there
hard to draw.
is there like a general like kind of rule of thumb type of thing where like after a certain year you're prone to seeing the 24 pin and before that you're just gonna be seeing 20 pins?
Not aware of a specific year, where it's always recommended to look at the manufacturer website of the actual motherboard to determine if you can't physically go into it, uh, what type of connectors are in there and required. But I would say if something has a PCIe, just PCIe, no PCI bus or any AGP, that would most likely give me a hint that I'm going to be using up a lot of that power on that bus. Once again, we'll still look it up and make sure that whatever it is that I'm buying is what I need. Questions or doubts on this slide? All right, the different type of connectors, all that spaghetti that we saw earlier. The traditional that we have here is a D-shaped Molex connector. That is the majority of devices inside your computer will contain, be your hard drive, your actual Blu-ray, your DVDs, even your tape drives would have this actual connector. As for maybe your floppy, which is the old antiquated one that I showed you with the 3.5 or the 5.25, they did use this little mini Molex connector. This is basically out the door. Only I think right now, maybe some fans are still using it internally in the computer and commonly not found anymore. As we saw earlier, there is another 4-prong connector just in the previous slide where they use to be able to connect the actual CPU fans. Any questions on a Molex connector, be a normal Molex or a mini Molex? Careful with these connectors, especially the actual mini one, as for some weird reason, Humpty Dumpty can actually be put backwards. If you try to forcibly fit it in, keynote, when you turn on the computer, it does not want to turn on. Therefore, just unplug everything, turn it on one by one, see if the fan actually turns on. So I would disconnect everything, just even the actual P1, turn it on, see if the actual PSU wants to actually react. Please, obviously, put the little power button to the motherboard. Humor me on that part. And then obviously turn it on with the soft part. Then go ahead and put the P1 and or any other ones. Obviously, P1 has to be in there. Sorry about that one. And any other connector that you want to be able to put. Otherwise, if you try to connect all of them at the same time, you're going to be testing all of them at the same time and creating the exact same issue. That's why we should only connect one device at a time if we ever have that type of issue. Any questions on a Molex or a mini connector? All right. Our power supplies. We have the L-shaped guy here, which contains the 3.3, the 5, and the 12 volts for the SATA. We'll also see here that we have the PCI Express, which contains a 6 one. We have also within here one key thing that was great about SATA is that it is hot swappable. Does anybody know what hot swappable mean? What does that feature mean?
It means you
You can
can
unplug it while
Inject-
it's on.
yeah.
Exactly. These are the only devices that we can unplug and plug without damaging. That is correct. Obviously, that would be maybe something in emergency where I see that my server, one of the drives went down in my RAID controller, and I quickly want to replace it. I don't need to bring it down in its hot swappable device. Questions, doubts on either the SATA connector or the PCI Express?
Yeah, I had a question
Dude.
on the SATA. There was one where it said like it was missing some pins and it wouldn't match up with a 3.3. Are there going to be some SATA connectors that are going to have more than 3 missing pins, or is it going to be the same thing?
Is this one of the questions at the end of the chapter or something like that?
No, it was part of the reading for the chapter.
Never heard of a SATA connector. Now, if you got to be careful, because if it's the other SATA connector, that would be the one for the drive. They're different shapes. They look the same, but they're different. They're both an L shape. Is that what you're talking about?
No, the power connector. It said like the first 3 pins are missing so they can correspond with the 3.3 feed pins.
Okay, we can look at it after at the end of this chapter. We can bring up the book if you like and see in detail what part of that chapter that was to try to understand better what they were. Okay.
I have a question.
Mm-hmm.
So it's hot swappable, so that means you don't have to unplug it, turn off the computer and everything. But you would still, if you were doing anything in the computer, you would still be wearing the anti-static gloves and all that, would you?
So yeah, you would have to make sure you're properly, either with anti-static glove or a bracelet or something. This would be an emergency fix. I would never recommend, even though if something's hot swappable, to do that unless if it is a server. And the majority of these servers, it's all integrated to the back of it. So it will be inside those rails and in the kit that I've explained to you before that they have for actual hard drives. And this kit will just slide out. It goes into the riser card of the actual motherboard, which gives the interface of both the actual SATA power and the SATA connection going straight into the motherboard. No need to go and open up the case. It's actually in the front panel where you could actually just release the hard drive and bring it out. This is where usually you use this. You wouldn't be opening up a case physically and reaching in for this cable.
Thank you.
No problem. Any other questions or doubts on SATA or PCIe? Best thing is to be able to recognize these and understand what's in there.
I got a
All
picture
right.
of one real quick, Diego, if you want. Show like what a RAID array would look like so they could kind of see how you just pull them in and out like a
Mhm.
hot
Go
flash.
ahead. Yeah, before we play tic-tac-toe here with the comments.
Share my screen real quick.
Yes. Feel free.
We see a RAID array a lot of times will look something like this or like this. And these drives are absolutely, you can just eject a single drive, you pull it out, you can unplug the SATA cables, plug in the new SATA cables, slap in another drive, and you're good to go. You can resync the drives at a later time, but it allows you to keep operating without powering down the whole unit and losing everything.
Look at the purple one there, the one all the way on the right. No, keep on going. That guy right there.
There you go.
Look at all the drives. That's the ones that I'm used to seeing, those blade servers. And every little purple one, you just press that little purple button and it pops it right out. And there's a status light that lets you know, since it is a hardware a RAID controller, it lets you know which drive is the one that's bad. Without even having to even physically look at the screen, it'll tell you which one. It has a little status light. It's pretty cute. Questions or doubts on where this power would be used and where we would actually try to attempt to use the feature of hot swappable? All right, back to the actual presentation here. Here's our pinouts and or connectors themselves. We'll notice the one that I love here would be the purple one. Anybody want to explain to me who's this purple one on the P1? Maybe this is an ATX 20 pin. So where would I have this 5-volt standby? What does it mean by that? I alluded to that earlier, why I said the P1 must be connected because of the fact that I was going to press that button. So what would, that's the hint I'm giving you. Big hint. Ding, ding, might be the answer.
That's for the power, I think. That's so it can turn on.
Yeah, so
right?
everything gets turned off, right? So it's completely turned off, supposedly. Well, this 5-volt standby is there, standing by, so that when you hit the button in the front, it says, hey, you, wake up. And then everybody wakes up. Hence why we should always unplug and discharge, because the 5 volts still running in there, and all these capacitors and things that are still holding electricity still have them in there. As far as we can see here, though, within the actual P1 connector, you have your positive 3 volts all in orange. You have your blacks, which everybody hopefully can identify always is the grounded. Then you have your actual negative 12 volts. You have over here your negative 5 volts and your positive 5 volts in red. If you'll notice, the ATX power only requires 12 volts and ground, while this device here, the auxiliary 6-pin connector, requires 3 grounds. 2 of them are 3.3 positive and 1 of them is 5. The 24-pin connector looks identical to the actual 20-pin connector. The only variance will come towards the bottom. You'll notice that on the ending here, we had the purple, red, yellow, red, purple, red, yellow, red, and play with me. Obviously, these are the last 4 on the end, which is your extra 12 volts, 5 volts, 3, and ground coming in. Over here in the center, you have your actual Molex D connector, the one that usually connects to all your internal devices, be your drives in the bay. You have the yellow, which is again the 12 volt, your 2 blacks coming in with your ground, and your 5 volts. Your small one that I said, that's on the mini for the actual floppy device. That one there, again, 5 is still red. You got your 2 blacks in the center, and the yellow is the actual 12. And lastly, your PCI Express is exactly the same. The only 2 different various things here is that you have either a actual 6-pin versus an 8-pin connector for the ones that are bigger. I did skip, sorry, your serial ATA power connector, which is the one for the SATA. That's the 7 or the L shape if you flip it around, which has your 3 volts here. You have your ground, you have your 5, you have another set of ground, and you have your 12. So here, maybe when you're talking about if it's missing these 3, maybe you're having a problem connecting, and maybe that's what they were alluding to, whoever was asking that question earlier about the connector. Was this the connector in the question? Is that Michael earlier was asking that?
Yeah, that answered that one a bit from the book. Yeah. I also had another question. Regarding the grounds, like say for the power connector, how do they determine like the number of grounds for the connector compared to like the other ones where they all seem to have the same number of volts and grounds?
You're saying in the ATA, the
Yeah,
power
because I
connector ring?
noticed the grounds and the other volts are like the same number, and then the connector, it's kind of like a different number. How do they balance that out when they do that connector with the grounds? If that makes any sense.
Yeah, I see you where you're saying that you have here total 9, but this one only has 6. Is that what you're saying?
Correct.
Truthfully,
Yeah.
I'm not a very great mathematician when it comes to electricity, but the only thing I can think of is if you have sufficient grounding, they're probably using the grounding doubled up. That would be my guess. In other words, it's just grounding itself to the same pair somewhere. I can't tell you which ones, but hopefully that would be an interesting question if somebody can answer that. I know grounding, all it does is allows you to release the overflow of charge. Therefore, it's really not used for flow of energy, if not a release of energy. So you shouldn't require power coming through it, if that makes any sense.
I noticed something.
Mhm.
There's one extra ground in the ATX 24 pin on the bottom right. Then on the 20, that only has plus 5 volts on the bottom right. All the
Well, no,
other,
they're identical though, remember. These two cables are identical for the exception of that they added these four on the bottom. So if we look at it, they both start with 3 oranges with a blue, sets of black. Exact same pattern until you run out of 20 because the last 4 are the new ones, which is 1 extra positive 12, 1 extra positive red, and 1 extra positive orange. And lastly, that black ground. Those are the 4 that are extra. If I take that away from the picture, they're basically twins.
I see. Thank you. I was just wondering why why don't they just make that extra one another 5 or 12 or but
Because
they made
of
it.
grounding, as you notice, then it looks like these 3 are grounded to that one grounding wire. Those 3 different voltages there are using that ground. Using the exact same idea as I said earlier with the ATA, where they're using doubling up ground, they're using that ground with these 3 positives. If you remember, that usually goes to either, we said to the GPU or some other device that's on the motherboard, sometimes directly, or sometimes it's on another spot on the motherboard, which we saw that it was sometimes detachable so that you could put it to that other spot. But a lot of times, the majority of the motherboards, the new ones, have 24 altogether. Any questions on the connectors? All right. Overall, the form factor is the one that's going to determine the size of your power supplies because the case itself is going to be a set in shape. It has the screws and slots and spots where we're going to go to, and ATX has a standard, and that it is right there for your actual desktops. It provides the P1 connector along the Molex SATA connectors. Depending on if you get all the bells and whistles, you could actually buy a gamer's one, which only brings the holes for you to be able to buy the cables apart and decide the amount of Molex connectors, the SATA connectors, whatever it is you need. You could actually purchase that one, and you'll see that they come actually grasped together like in a fancy black cable. You won't see the yellow, the red, and the black because each one is all individually wrapped, making them nicely cute and obviously looking professional compared to the one that we just saw a moment ago that all the cables are just loose and you can see all the yellows and blacks. As for the mini ATX and micro ATX, those obviously require smaller design of the actual power supply. So we need to be very careful whenever we're purchasing something brand new where we're not physically in front of the computer. Make sure that we get the actual model and or information correct to be able to determine the correct, obviously, size power supply that we need. And obviously, we also need to be able to determine the exact wattage that we need and the amount of rails. Natalia, if you can help me out here.
Rails. Generally, power supplies DC current is split into 3 primary DC voltage rails: 12 volts, 5 volts, and 3.3 volts. Each rail has a maximum amount of power it can supply. Powerful computers with advanced CPU and video cards require more power than some rails can provide. Multiple 12 volts rails with over power protection OCP allow to balance this circuitry and supply the required power. Today's power supply manufacturers produce single and multi-rail PSUs.
Thank you. So definitely, especially the more expensive PSUs, the fancy ones that are out there, they'll give you the specs of the amount that you can pull per rail. But sometimes you can buy with, obviously, if that one rail of 12 volts is not sufficient, you can get two rails of 12 volts because of the amount of amps. If you remember that some of these rails can only handle, so some of these power supplies will come up with more than just one rail per voltage.
What does the C and OCP stand for? Because the abbreviation for overpower protection is OPP.
Well, maybe they got sued. No, I'm just kidding. I really don't. Other property? Yeah. Okay, sorry. Bad joke. That's a wrap song. As for OCP, I really don't know. Why is it OCP? Anybody? Is in the book also OCP? I don't think so. I think that was a typo, to tell you the truth. I think it is a typo. Unless if somebody can contradict that. We'll take it as a typo. Any questions, concerns? A good question. Any other questions about the rails, and everyone understand what the rails are within that power supply unit?
No.
I really don't understand what the rail is by itself.
Okay. You know, we could actually use it exactly like a train. A train uses two rails to transport itself. Do we agree? Each single bar is considered a rail. Therefore, a train uses two rails. Please work with me. Now, you can use the same subway guy. He has two rails, right? Compare now maybe a fancier train which has three rails. These subways, they transmit, I'm not sure if you guys are aware, the electricity through the actual wheels, right? Some of these fancy ones. So this is what they're saying, is that there is inside the actual converter in the back, there is one rail or one physical bus, just like on the motherboard, right? One rail of 12 volt, another rail of 3 volts, another rail of 5 volts, and there's so much amperage that you can pull from that one rail. From that rail, they'll attach all those yellow wires that you saw. I believe yellow, if I recall correct, is the one for 12, right? Yeah, I got the color right. So you can just imagine all those yellows go into that one rail. All the rails, all the red ones go into the one rail of the 5 volt. And then the third rail in there is all the orange ones go into the 3 volt one, for example. Did that explain what rails are inside the PSU better?
Yeah, it did. Thank you.
Those colors never change or get updated or anything, right?
That is correct. Those are the colors. The red is the red, the yellow is the yellow, and the orange is the orange. As for the purple, we learned that one's a cute one. It's 5 volts standby. And the other one that's also very easy to spot is the blue one, which is a negative 12 volts. It's the only odd ones in there, besides obviously the gray. Questions? Doubts? That was rails. Now for wattage capacity, a power supply has its wattage rating for total amount of maximum load. That's why we need to know what's the watts, because the amount of load, how much you could actually pull from there is ration. It actually says it in the back of it, and it'll tell you either 500 watts, 850, whatever it is that you purchase, depending on the ratings itself. These wattage capacities are listed in the documents or in the label in the back, and we need to be fully aware, obviously, of the full power consumption. And the other thing is, please take note that the video cards obviously draw the most power because it's almost its own mini computer inside a computer. We agree that? Can everybody agree that the latest and greatest GPUs is similar to having a mini computer inside a computer?
Yes.
Yeah.
Okay. Because it has its own memory, it's got its own GPU or CPU built inside. It's got a lot of stuff that a regular motherboard has. All right. Questions or doubts on wattage capacity and why we need to know? So if a client comes up to you and is angry, explains that his new PCs from Europe only works with 220 and he asks you why he can't use it here, how can you communicate with this person to try to explain to them why this European 220 is not going to work here?
Tell them it was made in Europe.
That'll work. We'll specifically say it was made in Britain. That explains everything. No, but that would be cute. In layman's terms, I mean, not the correct voltage. Hopefully they understand that, or that type of electricity is not used here.
I was gonna say, I was gonna give him an example, like picture, like the thing that you said, picture a fire hose, like yeah, that example you gave. I don't know what you said.
Yeah,
I
the
can't
fire
quite
hose
picture.
connecting it to the back of your house.
Yeah.
If you put the fire hose to the back of your house to the connection, it just doesn't make sense because it's just gonna be not gonna fit, right? Even if it fits in, the water, the flow that comes out on the other side is not the same as putting your regular garden hose to that, which is 1-for-1, and it will turn on. And the worst case scenario would be a person that's going from the U.S. and Lázaro, he's the perfect case, who went out to Europe and did it the other way around. That's equivalent to sticking now the garden hose onto a fire hydrant, which he blew up. That was cute. Therefore, obviously, when you tried to connect that, I don't know if you guys ever played with a fire hydrant, but us when were in New York and New Jersey, we used to open up those puppies in the summer, and they were fun. Questions, doubts? Okay. We need to be able to determine the exact wattage, as we said, to consider all the components that are inside your USB fire wires, and you want to add, according to CompTIA and everybody else, 30%. Purchased by, obviously, by looking at all the different devices that you have in there, adding up the wattage to be able to come up with that, and then, multiply by 1.30, and that should hopefully give you the 30% more. I would never, ever, ever do that. Anybody want to know why? If that's the recommendation, why should I use their exact recommendation? That is the minimum. I'll give you a clue.
Play it safe.
If you do 30 and that is the minimum you need space, right? For growth. What happens when I go and add a
When
second?
you add more stuff, then it won't be enough power.
Exactly. We remember when we first turn on the computer, we need that extra pull. That first initial start power is more than its actual running power. Therefore, if I start adding components in there, even though I have space, now I'm below the 30% threshold, and might run into that problem. So I usually recommend 50. You need to learn from the book that it is 30, but I'm just telling you a real world scenario. If you don't want to wind up buying another power supply unit, and it is for yourself, I strongly recommend allowing 50%. That's if you're planning on upgrading anytime soon and putting more stuff in there. That's up to you.
It also lasts longer too.
Because of the fact that now, instead of, that's a good point, thank you. Instead of actually pulling at 70%, just like your car, if you have a very fancy car, if you're one of these sports cars, if you run it at 100 miles per hour, its RPMs are low because of the fact that this engine's made to go, per se, a Lamborghini 210 miles per hour. While you go get yourself a little golf cart kind of engine, just play with me here, and try to run it at 100 miles per hour, it's going to be going. So It's on power consumption, and the load on it is gonna be on the full, all the way on at that 70%. Where here, if we leave it at the 50 or 80%, whatever, depending how when it turns on, we leave it at the 50, it's not gonna be running so hot. It's not gonna be overworked. So that is a good point. Thank you, Lázaro, for bringing that up, since you are the expert in destroying things. I mean, in this subject. Sorry.
I have a question. Will we be getting into the power supply ratings, or is that not important?
Power supply ratings in reference to?
Because I have a power supply that's gold rated. I think it's 80 plus gold.
Nat, we talked about that before we.
It'd be bronze if it's 80. 80 is bronze.
No, it's an 80 plus gold.
We talked about that right before you got on this morning. That won't be asked, but it's good to know about the standards of ratings that they give power supplies to ensure that number is accurate, because you can say you have 1,000 and it's not 1,000. So those ratings are more of a industry standard to make sure that they are holding their accuracy. But for CompTIA, it's not a mandate, and you won't come up in any question set.
Yeah, and the rating is more beneficial for you. So let's say they tell you that this thing is at 1,000 watts, but it's rated for 50%. That means that it can run at 500 watts without giving you a lot of problems. It can do 1,000 watts, but if you want good performance, it could only really be running smoothly at 500. Its peak is 1,000. That makes sense? That's what the rating, if you're alluding to the ratings on it, that's what they're talking about. One thing is how much it could actually do, what's the peak initial power on start versus the Serenito when you're supposed to be coasting on the normal running, which that's what they're talking about. Hopefully that's your question. I'm not sure if that's what you meant.
Yeah, no, I was just saying, like, or were you guys gonna cover that, or
I don't think it's a mandate to know exactly that intricacies inside CompTIA asking you that question. Wattage will be, that I'm aware of. Understanding what wattage is and determining this little 30% and knowing that, yes.
Thank you.
Okay, no problem. Now I believe I pass it off to Lázaro.
Hold up, I'm trying to fix my Xbox from 20 years ago. All right, so we're gonna talk about connectors. Well, more like we're gonna play a game, actually, with the connectors that Diego's mentioning. So take a good look at this picture. Now that you take a good look, we're going to skip to the activity. Lots of pictures here. Lots of pictures. Lots of things to do here. The question is, what is what? Now, on the teacher screen, we can play the game, start playing around. We can go feel free on your own trying to connect things. But in the meanwhile, at least hear what we're saying. So what connector is this that Diego is hovering over right now? I wonder what that could be. And I see an extra pin too. Look at that. Oh, I wonder what that yellow and that extra pin could mean.
It's a PCIe 6+2.
Ah, let's see if that's correct. All right, let's click that and that. Ooh, good job. All right, we got one. Let's try another one. Let's see about this one here. It has 4 yellows, and I see, I don't know, I see something. Question is, what could it be?
The CPU 4+4 pin.
I see 4 yellow and 4 blacks. I'll give you that much of a hint.
Let's give it a shot. Let's try.
Oh, they said something? I'm sorry, I didn't hear somebody.
Yeah,
so what did they say? Sorry.
Ardio said CPU 4+4.
Okay, thank you.
In.
Let's give it a try.
Very good job. You notice it was 4-4. Very good. What about this one right here? I'll be surprised if somebody gets this one. Now, it was on test out, by the way.
Fan connector.
Oh, I heard fan connector. Let's see if that's correct. Oh, good job. All right, let's do a harder one. I wouldn't know if this is harder, but
That's 24 pin.
That's
20 plus
okay. Let's see. Is there an actually 24 pin here? I don't see a 24, but I do see something
20
similar.
plus 4.
20, 24. 20 plus 4.
Correct. Very good. Most of the time with those motherboards, they're always going to have 20, then plus 4, just to make it easier to be compatible in case your motherboard, I don't know, doesn't
If it's
need
an
it.
older model, yeah. If it's an older model, it's going to require the 20, while if it's a newer model motherboard, it will require the 20 plus 4. So they usually try to facilitate that.
Yeah.
So what's this guy here?
Yeah, this is old one. Diego was mentioning it. We somewhat used
Molex.
Molex, yeah.
Molex. Good job. Good job. Ooh, okay. That one's going to be a hard one. And this is something that I have actually. I wonder what this could be.
SATA.
SATA what?
SATA power connector.
Power connector.
Good job. Good job. Well, we only got 2 more left. Now, this one's a harder one. What
The
could this
floppy
be?
power connector. The flop.
Really? How do you know? How do you know that's a floppy power connector? I want you to look at the colors.
Process of elimination.
I already answered it.
The color?
No, I don't know the color. I just selected it on mine and it was right.
It's correct, but the question is, how do you identify it just on the color? Diego was mentioning it.
There's yellow and black on there. That's all I can tell.
So pretty close. You can tell that it's a floppy disk because it has yellow, which is 12, red meaning 5, and it has 2 grounds. You may actually get a question like this in CompTIA where they may not show you a good picture, and then the only way you can identify it is with those colors. So that's a little trick you can learn. Trust me, sometimes the pictures are not very good, especially for the floppy. And then the last one, well, it's right there. And this one is the PCIe 8. It's all together. All right, good job, guys. Good job. Let's see, the majority of the class got it. That's good. All right, I'm gonna pass it down to my next partner in crime.
I have a quick question.
Yes.
What is the function again of them being broken up versus put together, like a 4 plus 4 versus 8?
Great question. Compatibility. And also they want to be cheap too on top of that. So let's say you have a graphic card as an example. Your graphic card only accepts 6 pins. If you only had an 8 pin and you cannot separate 2 pins, then you can't use it because it won't fit in correctly. So by having that little tab where they can kind of like separate it, you can convert an 8 into a 6 pin. Think of it like that. Same thing with the motherboard. Like me and Diego mentioned, some motherboards only accept a P1, which is just 20 pins. Those older boards only need that. And if you had a 24, without the ability to separate those extra 4 pins, it won't fit.
Yeah, because the new power supply will come with that cable that way. You got to understand these manufacturers need to be able to build in bulk. So it's cheaper for them just to have the actual cable that's able to split into those 2 pieces versus selling 2 models of the exact same power supply.
Economies of scale.
It's more of convenience and cost of the manufacturer.
Any more questions, especially about the pins? Because that's a good question.
Mm-hmm. That one always messes with people, especially when it comes to the test and they throw you those curveballs and they ask you if it will work or not. Like I did, I think in one of the questions, if when the fan, if it was supposed to be for 4 and it only has 3, if you could use it for the CPU.
Yeah, that's maybe my next question. How do you, like, when does that rule apply that you can apply something that's a different amount of pins?
Well, those are the ones that you heard so far. It's been the CPU fan, the P1, where it's coming from the actual power supply unit, it gets split because of the motherboard only requires 20. So you just disconnect it and you put in the 20. The same thing, if the motherboard only has 3 prongs coming up for the CPU fan, that extra one, which means that the BIOS isn't a fancy BIOS, that's all it's telling you. It cannot regulate the speed of the fan. The fan will turn on, it will spin at a constant rate, versus all these gaming performance ones, as we saw when I went into my Alienware and I turned on the actual power. It sounded like if my computer was about to take off because all those fans just started pushing and the processor was just waiting to be used. So in that point, since it's not a fancy computer, the fan is still going to spin. There's nothing that's really impeding from that computer working. The same thing with the actual GPU. If the GPU only requires 6, it doesn't require the 8, then again, that connector is able to just take off that extra pair, goes back to the 6, and allows you to connect it directly to the motherboard or the device, depending what it is.
That's great questions. And now you know why you have an extra pin, right, Benjamin? I'm reading your comment.
Correct.
Well, I guess you're ready for the new graphic card that you mentioned. Hopefully you have that extra pin. All right.
Passing out to,
Yep, we only got a couple minutes till lunchtime, but we can probably get through steps as we usually do.
If you guys, sorry to interrupt you, if you want to pause the recording there and go to lunch, I mean, it's up to you guys. I gotta come back at 3 p.m. That'll be 12 Washington, Miami Eastern,
3 and finish up the
3
last
p.m.
couple slides.
All right.
You said Kevin?
No, Kelly.
Oh, sorry, I couldn't hear you clearly.
All right. Oh, I guess we left off steps for removal and install of a power supply. Everybody should always remember step 1 is it's the same step for anything you want to do in working on the inside of a computer, which is what? Anybody?
Turn off the power.
Turn it off and
Hold the power for 3 seconds.
Unplug it.
Oh, plug, yeah.
Yes. Then yes, you would discharge it after that. I will tell you, if you ever get hit by 110, it's not pleasant. 220 is really unpleasant. So depending on where you are.
And the amount of amps, apparently.
Yes, absolutely. Anything more than, was it 1.5 or 2? And that will cause some serious health problems. So step 2, after you've opened up the side panel on the computer, you want to go through, follow that, the power line out of the power supply, remove all of your connectors from your motherboard, CPU, graphics card, everything. You want to get everything unplugged before you do it. You don't have to necessarily unplug the connections from, the graphics card to the actual motherboard. You're just worrying about the actual power supplies. Get all that removed, then you go to the back of the case. Make sure you identify which screws are associated with the power supply, because sometimes they would be for the back panel of the computer versus the power supply, but you'll see a nice little cutout around them, usually 4 to 8 screws, I believe. Go ahead, draw all those out, then you can actually safely remove the whole housing of the power supply. Is there ever a case where you would open up that housing to look inside to see if you can repair?
The power supply housing you're asking?
Yes. Is there ever a case where you would open up that power supply casing?
Not unless I'm an electrician.
There you go. Exactly. As a tech, So power supplies are inexpensive. They're also dangerous. So it's just, you know, might as well just swap it out with a new one. You can send it in to have it tested if you want. They actually have power supply testers you can use, stuff like that, but you never want to open the housing. And once you get it successfully removed, you can swap it out with a new unit, and it's pretty simple. It's only 3 steps. You follow the same steps in reverse to put the supply back in. You seat it properly back into the housing, insert the screws on the back, plug in your power connectors to all your pieces. Make sure all of your components are plugged in. It does not mean you need to use every single plug from the power supply, because many times you are planning for the future when you're buying a power supply. You want to get what's the percentage over on wattage you want to go?
50.
30.
Well,
30.
30.
Buy
30.
the book is 30. Buy the book is
Yeah.
30, but I recommend 50. But
Yes,
buy
30
the book
minimum.
is minimum is 30.
And, you know, for the exam, it will be 30%. But yes, for personal, yes, you may want to go 50 just to give yourself a little more future proofing. All right. Next, take a little quick quiz based on what we've done so far. All right, looks like we're still waiting on just a couple.
Woo, I get to play on the stove. Take your time. Woo. I'm sorry. I'm on sorry.
Man, that penguin cult is growing by the games.
Hey, don't blame me. I love penguins.
The happy feet cult.
Remember, guys, when you select, you hit start. I think we got majority of
Waiting on a
people.
couple more. I think we've got 17.
You have to hit the little start after you select the character. You gotta hit the start. There we go. Hey.
All righty. All right, I guess we can get started. Move ahead.
Hey, Michael. Woohoo! That's the first time somebody actually beat her. Look at that.
We need to make that a 3-question quiz because I obviously was sprinting to the top, but then cardio kicked in.
Yeah. All right. Just a couple quick questions, I guess. What would be some symptoms that your power supply was going bad or that you had a bad power supply? What do you think would be some things that you might experience?
Flickering. Smell.
I don't know about smell.
But flickering maybe, but like power.
Intermittent connection.
Smoking.
Smoking. I think if your computer starts smoking, you get a lot more problems.
The voltage.
Not starting up.
How about nothing? You press the power
If it doesn't
button.
power on, or if it powers on and it shuts off.
Yeah. You know, or if it's from a IT perspective, power supplies can fail one of two ways. They can go quick and then nothing works from that point forward. It's just done. That's pretty cut and dry. You open up the computer, you flip out the power supply, close it back up, turn it on, and everything works great. That's the ideal way they go. Unfortunately, sometimes they go slowly. And this tends to be one of the more difficult things that you can try to diagnose as an IT professional. So on this one, Shiloh, can you please help out?
Troubleshooting a power supply. Power supplies fail in sudden death and slowly over time. With sudden death, the computer won't start and the fan in the power supply will not turn on.
You're
Verify
correct.
that electricity is getting to the PSU before doing anything. PSU will not start unless connected to a motherboard. If you want to test a PSU without a motherboard, use a power supply tester. Power supplies die slowly when one of the internal electronics begin to fail. The failures are always intermittent and tend to cause some of the most difficult to diagnose problems in PC repair.
Thank you. So if we're starting to see intermittent failure of, say, our graphics card, what would be one way we could test it and verify whether it was the power supply or the card that was going bad?
Try to play a video or a video game or something that uses that would use that card.
So it works fine over time. You put the video game on today, it crashes. You put it on tomorrow, it works just fine. So you've got intermittent issues. Is that intermittent issue with the card or the power supply? What's a way you could possibly test that?
If you're not
Maybe
losing
to
power.
try card on
Try a
another
different
computer
card.
for some time.
That's one thing you could do. You could swap it out, try it in another computer. What about using a multimeter, checking the power coming from the power supply to see if it's consistent? You're not seeing big drops. You know, it's coming through at a regular rate.
Well, why was the answer false on the using of the multimeter in
Not
that
inside,
quiz?
because he said to pop it up open. He was popping the hood open. You're not supposed to pop the hood open. In this example he just gave you, you're actually going to go to the Molex connector and put in the two prongs, one onto the negative, which is the black wire that they give you, and one onto the positive, be the yellow one for the 12 or the red one, which was 5. So you wouldn't open up the case.
Yeah, the question was specifically opening the power supply up, the casing, versus checking the cables coming from the power supply to see if you're getting a consistent power source.
I see. I read too fast. Thank you.
Huh?
That's going to happen a lot on the test, so be very careful on the real test. They're going to throw you a curveball where low and outside, and it's going to look sweet right over the plate, and all of a sudden it's going to drop because you didn't actually read the whole question and you answered the wrong question. You got it right, wrong question.
Yeah, Josh, don't go for the low and outside, Josh.
Or you're reading the answer looks great, and it's answer A, and it, you know, you read the first 5 words of that answer, it looks perfect, so you check that one, and then later on you realize it was answer C.
Yeah, Josh is my competitor, my rival. I'm also very good at that.
So yeah, just, you know, when you start seeing intermittent component failures, those are really tough because you don't necessarily know if it's the component itself going bad or if the power supply is just dying a slow death. So 2 ways you could do it. You could check it with the multimeter, or you could flip out the power supply. If you're in an enterprise environment, you probably have a few sitting on hand. It's worth, you know, pulling it off, putting it on the tester if your company lets you have a tester. If not, put it in another unit, test it in another unit, or put another power supply in that unit and see if that clears up your problem. I think we have come close to the end.
Yeah, this is the end, my friend. That is correct. Overall, hopefully by now we have all understand and be able to identify the characteristics of the power supplies and their connectors, understand the various types of connectors and the devices that they're plugged into, especially the motherboard plethora of connectors that we have, be for the fan itself and or for the ones like we saw for the P1, which we have the new one, which is 24, or for the old one, which was 20. We need to be able to just to identify and understand those cables that are coming out. The colors are not going to play with you. They're going to stay the same. So that we need to understand. And that's going to help you also, as Lázaro stated, especially when they kill you with those pictures that you can't see the tip real good. But if you see that it's all yellows and blacks, and it looks like if it's 4 of them versus one that has 4 and it has the yellow, a red, and 2 blacks, hopefully with that example he gave you, you should be able to identify the variance between the PCIe 4-prong one and the actual mini. Trust me, they're gonna mess with you. They'll probably put it down like this, not show you perfectly the head on purpose, just to see if you could be able to recognize it from afar. Because that's what you should be able to do, is from afar, recognize this actual connector. Lastly, and hopefully be able to not only install or remove the actual power supply, understand that we're not supposed to actually open it up when we're going to identify the common problems with it. One of the ones that you'll see a lot is because we're dealing with electricity, as they stated, we said that these units use those volts, be 12 or 5 or 5 and 3, to be able to create the ones and zeros. Therefore, I'm not sure if your chapters have actually covered this. It will also, you need to know this for networking, it does the exact same thing. And what you need to understand is, let's say from 12 to around 8 volts is considered a 1. Just giving you an example here, ballpark figure. Now, I said the other one was 5, right? But I just told you 8. Why? Because anything that may have dropped below 8, right? Between that area of 7 and 5, it will be considered a retry because of the fact that we understand that voltage may, as he said, come over. So that 5 may be surging over because the power supply is giving me issues. That's why it gives that threshold. Now, anything that's between the 5 and almost that 3 again would be the 0. Anything below that would be considered a retry. As for the smaller devices, it does exactly the same thing, but it does it with the 5 and 3, and it plays with those to be able to create it. We need to understand this, because if we don't understand this, we won't understand why all of a sudden I'm getting all these intermittent issues. I've replaced them. I've seen it. I've worked once when I was the RMA manager for a company here in Florida that I dealt with Dominican Republic, and a lot of the shops would be sending out all of a sudden a whole bunch of different parts, and when it came back from the manufacturer, it was good. So I just paid to get something repaired that was actually working. Bottom line, it was a lot of power supplies that came in, and because they actually build these, it was called Lehman Miami. So it was mostly like uh, um, you can actually buy and create these pieces by parts, just like if you were gamers PCs back in the days. So obviously, unfortunately, with that lot of bad power supplies, it created this false illusion. So we need to be able to, as some of you said, be able to go and test on another computer, a good computer. So what I did is I asked my boss if it was possible that I can actually challenge the action of my whole team, which the shop was giving us bad parts, were RMA, return merchandise authorization. So what I did is I challenged my people, which unfortunately in Dominican Republic, there is no AC. Therefore, they need to be in a warehouse collecting all of this information, right? We have a bunch of cards and stuff that's supposedly bad, and I needed them to create a computer. The bonus was that in their 2-hour lunch, that I would extend their lunch to 2 hours, I would allow them to play the video games. Hence, if you guys get where I'm going with this, they were actually testing the components, because the moment that they were playing Doom and the actual device failed, this computer that they just built with supposedly good parts, they had to quickly troubleshoot that computer to be able to get into the game that everybody else in the department was able to play. You could just imagine how many spare parts they had ready to test so that they could be able to play. And they were excited to be able to work while they were actually at lunch. Either which way, I was able to obviously determine that the shop was giving us parts that were not legitimately broken, because of the fact that we were able to determine which ones and were the right ones that were broken. And we were able to determine the root cause of actually being a lot of power supplies units that the shop was using. Questions or doubts on this? All right, let's stop the recording here. This concludes T11. I pass it back to the TAs.